आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
We bring you all a podcast series on STEM popularization, that is, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, the Government of India. Program is produced by Media for Community Foundation.
This is Manjeet. Welcome back to the podcast from the Indo French Center for the Promotion of Advanced Research, also known as CEFIPRA. Today, we are diving into a fascinating frontier of material science, an area with the potential to reshape electronics and even quantum computing. We are talking about two topological insulators. This groundbreaking project is backed by CEFIPRA and unites two brilliant minds, Dr. Sebastian C. Peter from the Jawaharlal Nehru Center for Advanced Scientific Research in Bangalore and Dr. Mary Aude Masson from University Paris, Diderot. Together, they are exploring the intriguing properties of these unique materials. Now let's listen to them for more information.
Hello, myself Sebastian Peter. I'm a professor at JNCSR in New Chemistry Unit. I work in the area of material chemistry. We are expertise in developing the material for various applications ranging from condensed matter physics, energy and environmental application. We use various chemical methodology to tune the material designs, and we try to understand the structure property relation. And the CEFIPRA project, in one such way, we try to understand the properties of this material in collaboration with the French team at Grenoble. As a part of this project, I had a wonderful collaboration with Mary. She is from Neil Institute, and we could able to utilize the facility, advanced facilities present in France, such as magnetic measurement or resistivity measurement and high pressure energy experiment. We could able to explore the properties in a very useful manner, and that help us to actually improve the the fundamental research that we are currently doing at the JNCSR. So in this project, the subject we handle is nothing but topological insulator. So topological insulator is nothing but it's a surface property. Basically, at the core, it acts as insulator, but at the surface, it is like a conducting behavior. So it's actually one of the upcoming techniques, especially used for the technological development in the spintronics and say for example quantum computing. We are still in the early stage. As a material scientist, we could able to develop the material, and Mary from Neil Institute, she could able to measure the properties of those material, how they are behaving at the surface. Say for example, when you apply the pressure, this material can show conducting behavior. And if those material, showing the conducting behavior at the surface and insulator at the the core, then we call it as a topological insulator material. If that behavior is actually a match with or on par with the state of art material, we may able to take it for the technological application. That's what the whole aim of this project. So as a part of this, I had a student and Dr. Ramarao. So he could synthesize various materials using like a high temperature synthesis, even using actually certain modification of the synthesis by Bridgman crystal growth method. or vapor transport method. So we could grow all these crystals, single crystal. What we have done using the facility in JNCSR, we characterize those crystals and try to understand the crystal structure of those compounds. And we also did some preliminary characterization collaboration with the other my co-PI in JNCSR, Professor Chandravas Narayan. He's a part of this project. So in his lab, we could able to do high pressure Raman, but we don't have the facility for high pressure resistivity or high pressure or ARPUS technology, etc. and all. So this proposal actually turned out to be very strong support from Cefipra, French collaborator. So where she could do all these experiments that we could not do in JNCSR. It's a kind of a win-win situation for both parties. So I am a chemist and she's a physicist, and we utilize our expertise both sides efficiently to project this what you call the proposal as a successful. And during the course of this project, we could able to publish 3-4 publications, and a couple of them are still we are in the process of finalizing. So hopefully maybe we can finalize those project actually as a publications very soon. So all in all, I want to say that it's a kind of a strong collaborative platform to develop a technology, develop the materials which can be efficiently utilized for the technological application such as spintronics or quantum computing. That's what overall aim of this project. So this project started during 2017, 2018, and then we completed by 2020, around that, in the middle of the COVID period also. But during, or pre-COVID, time, we could learn a lot from this project. For example, as I mentioned, I am a chemist, but I learned that how we can design a material for this particular certain applications we proposed. Here, during this process, we developed this material with a surface property. What initially we proposed actually topological insulator, but we are extending that knowledge of material design strategy for other techniques. So because conductivity at the surface is a technique we can even propose for superconductivity or point contact superconductivity, or we can propose for thermoelectric properties. These are all well connected properties of a material. So by this project, or with the help of this project, my students and myself learned how this can be extended to different application. We are also looking for this application whether we can exploit it for other properties like anything such as two-dimensional surface technology or surface properties. So we are trying to explore that one. So then we also can utilize this for say for example hydrogen production. So one such discussion so happened, maybe this what you call two-dimensional material or this topological material may be explored for us an efficient hydrogen production material. That's a current active research we are doing. We are especially concentrating on hydrogen production or fuel cell. These are all can be explored. The design strategy that we have learned during the course of this project. So we could learn a lot, and this project was very successful, and my students also explored the facility and expertise that we got it with the support of our PI or French partner, our co-PA and French partners involved in this project.
This Indo French project aims to synthesize and study new topological elements. The researchers will use a variety of advanced techniques, including X-ray diffraction, electron microscopy, and ARPES, to characterize the structure and electronic properties of these materials. They will also investigate how applying pressure can alter these properties. This is Manjeet now signing off, and we will meet again with another project with another scientist.
आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानी।